Hey guys, welcome to this session about REST interfaces. In this session, I don't want to talk about how to make REST interfaces. That's really simple, it's a right click. But I want to talk about my experiences with REST interfaces, what to do and what not to do when you're using REST interfaces. So today, I want to talk about the modules, structures, the on before request, the on before request advanced, and the on after response. Finally, I want to end it with a Forge component called the multi-part upload. Let's get started. So, the modules, let's get started with that. In OutSystems, it's a best practice to divide your modules into business concepts. Sometimes you want to divide it in more modules just because of technical issues. When you're using REST interfaces, you have two kinds of interfaces. You have the ones you expose, and you have the ones that you consume. When you're exposing a REST interface, what you're actually doing is you're making your data available for external systems. When you're consuming a REST interface, you're making the data from external systems available for your system. So let's take a look at it technically. What you're actually doing is, when you consume a REST interface, you're going to reference that module from your system. And when you're exposing your REST interface, then you're going to reference other modules from your REST interface module. And there's a danger when you're doing that. You're creating circular references. So if you have one module that's exposing and consuming at the same time, you can have a direct or indirect circle reference. To avoid that, you make a separate module for your consuming REST interfaces and a separate module for your exposing REST interfaces, but still based on business concepts. The reason why I do this based on business concept is because an external system can expose a lot of REST APIs, and they can have different business concepts. And if you consume them in one module and you're not using a certain business concept anymore, you can't get rid of the module because there are some business concepts that you still are using. So always separate them on business concept. This is what your application could look like. You have your core module with all the entities. You have your integration layer that consists of two modules, one with the consumed interfaces and the other one with the exposed interfaces. And last but not least, you have your end user module. Okay, from the modules, let's move on to the structures. Most of the REST interfaces that you consume will have a JSON structure that sends you the data. Sometimes you'll have binaries, but it's mostly JSON. These JSONs we convert into structures that we can use in OutSystems. OutSystems converts the JSON automatically to its own structure. And the structure belongs to that REST API. Automatically the structure goes to public no. It's not public for other modules to use, and keep it that way. The reason why to keep it that way is because usually you have a lot of attributes and most of them you won't use. If you're going to use all of the attributes and send them along all of the applications, then it will give you a performance problem. So only use those attributes that you're going to need. And besides that, when something changes in the external system, in the REST API, it doesn't affect the rest of your system. The only thing it affects is your integration module, and the only thing that you need to change is the JSON attribute that's consuming the REST API. So what to do? In the server action that makes the REST API available to the rest of your application, just map the attributes that you need to your own structure that you will use in the rest of your application. When working with structures, just one small tip. There is a hidden field in the structure, and that's called name in JSON. This field maps your structure to the JSON that it produces. So if you're having any problems that you don't get any values in your structure or in your JSON, take a look at that, because maybe you need to fill it, or it's already filled by someone else, and it's something that you easily oversee. Don't forget that. For this example, I've consumed the WeatherStack getCurrent method. I've made it available through the getCurrentWeather server action to the rest of the application. The action does not have any output parameters yet. If we take a look at the response of the REST method, then we see that the response consists of three structures. There's information about the request, the location, and the current weather. Each of these structures has a lot of attributes, and that's information that we do not need for our application. It only causes performance issues. The best way to handle this is to make your own structure. Select and copy only those variables that you need from the API response and paste them to your own structure. In the server action, just make an output variable of your structure and assign the response of the API method to the output variable. Because you copied the attributes and the names and the data types are equal, OutSystems will automatically do the correct mapping for you. One thing I forgot over here is to make the structure public. Don't forget that, but no worries, you can't publish if the structure is not public. The name in JSON property can be found as a property of the attribute. If you double-click the structure, it will open a dialog in which you can see the properties for each attribute of the structure. If you have problems with incorrect mappings, then check that there are no typos in the name of the attribute or the name in JSON. Remember that the mapping is case sensitive. Okay, so after the structures, let's move on to the onBefore request. The onBefore request, as the name says it, is the action that is executed just before the request is sent to the REST API. This is your last chance to manipulate your request. In this action, you can manipulate your headers, query parameters, your base URL, URL path, and your request body, be it a text or a binary. Most of the things that you can change, except your base URL and URL path, are available by input parameters for the REST API. So let's say a header, a URL header that has authorization, you can put as input for your REST API. And then you'll think, yeah, why do I need it then? On one of the projects I've been on, there was an ADFS server that returns a token, a JSON Web Token, that you can use in your header to authorize the call to the REST API. The only thing is that it was base URL based. So you need the runtime URL to get the correct access token. And you can do it by making a side property, but for every REST interface you have to have a separate side property, and you have to change it constantly when you're switching from environment. There's a generic way to solve this, and that's make an on before request. In that on before request, you have your base URL. That's the runtime URL of your REST API. And with that URL, you can just simply call the ADFS server, get back the token, and add that as a header to the request. So besides adding data to your request, you can also change values in your request, in your on before request. And even so, you can change your base URL and your URL path, and that means you can completely steer your REST API to a different location than the one specified in Service Center. And that can come in really handy. One of the previous projects I've been working on, the client had a lot of locations all over the world, and every location had to access a different endpoint based on that location. So the specification of the REST interface were the same, only the complete URL path was different. So how to solve it? You just add an on before request, and in that on before request you see what location you're dealing with, and if you can't get the location, you simply add it as header information in the REST API, and you can read it in your on before request as well. And depending on that location, you just get the right endpoint and change the base URL and the URL path for that. If we take a look at the on before request, then you'll see that the input parameter and the output parameter have the same structure. The output parameter, the customized request, is the request that will end up at the endpoint. So the first thing you want to do in this action is make sure that the customized request is equal to the request. From there on, always use a customized request. One tip, when you're done with your action, just check everywhere and see if you're using the customized request. If not, just change them, because it's an error that slips in easily, and before you know it, you'll be debugging and going crazy to find out what's going wrong. You can add or modify your values in your on before request. Besides that, you can always add your request body as well. The thing that you can't do in your on before request is delete headers or information. For that, you need your on before request advanced. Another thing that you can't do is complex data manipulation on your request text. It's possible, but it will take a lot of effort for you to do it completely in OutSystems. So with that said, let's move to the on before request advanced, and we'll see how to do that in there. Okay, so the on before request advanced. What is it? You're gonna make your own extension, and that sounds really complicated, but that's something we'll do in another video sometime. But for now, let's focus on how to get it working for your REST. In Integration Studio, you just create your extension, and what you have to do is add the REST compatibility API to your .NET code, and that's easy. Just add the namespace outsystems.runtimepublic.rest, and it will give you access to your REST request object that's going to be used. Once you've built your action, your extension, just drag and drop the action in the on before request advanced, and OutSystems will automatically assign the request object and make it available in your action. You can use the namespace outsystems.runtimepublic.rest and add it to your using directive to get access to the REST request or the REST response objects. The REST request you use for your on-before advanced, and the REST response you use for your on-after response advanced. With the getCurrent method of the REST request object, you'll get the current instance of the REST request. Use this method outside of the on-before request advanced, then it will return null. The same applies, of course, for the REST response and the on-after response advanced. For the request object, we get access to a few methods. In BASIC, you get access to the same variables as in the on-before request. A small tip, you can always add input and/or output parameters to your extension method. This is convenient for debugging purposes, but it can also be useful in your extension method. Think about site properties or labels that you want to use in your extension method to rebuild your request body. In this example, we will just act like we're manipulating the request body. What you have to do, get the request body as a text, customize the text to your wishes, and then do not forget to set the request text to the newly changed text. Otherwise, nothing will change. When you're done with your extension, just publish it and reference the action from your module containing the consumed REST interface. So, what do you use it for? As I said before, you can remove headers or other information from your request. Besides that, you can also use it to make complex manipulation on your request body. One of the things I've been using it for in one of the previous projects is when I came in touch with dynamic key JSON. It sounds really complex, and it's something, be happy, it's not something that's really common. So most REST interfaces don't use it. But what the dynamic key JSON is, the key value mapping, the key is here the value, and the value is the object. So for instance, let's say you have a customer with an ID, a name, age, etc., then the attribute customer will be the ID, the real technical key, and the object will be a key value mapping of the name, the age, etc., etc. A picture says more than 1,000 words. The red are the technical keys, those are dynamic, and after that you'll find the record that belongs to that specific technical key. It looks really easy, but it's hard to build in OutSystems. So OutSystems doesn't support that, and if you want to be able to access a REST API that supports this, then you need to make your own customization in .NET. You can do it in your on-before request, but it will make it really complex. And when you do it in your extension, it's kind of simple. There are two ways to do it. One is feed the extension action a list of values, key values actually, and then you know in the REST interface what key to switch with what value. Another way to do it is have standards. You know which key value mapping are dynamic JSONs, so you replace the key with the value and you have the object below that. Just make sure when you're using the second one to end the object with the same key value mapping, so that you know that you have to terminate the object at the end. Use the on-before request advanced for deleting values and modifying your request text. For other things, just use your on-before request. With that said, we still have one that's the on-after response. In the on-after response, it's actually the first thing that's executed when you get a response. from your REST API. So what are we going to use it for? One of the things that's overseen a lot is the errors. People usually tend to only test and build the happy flow. What happens if something goes wrong? A lot of the REST APIs either give you a different HTTP status code than 200, or they give it 200 and they give you an object with an error message and a status code. Here's the tip. When you're adding the REST method, test the REST method first. You'll get a request object back, and just copy that object to your request parameter. The structure will be automatically generated in OutSystems, and don't only take the happy flow, also make one of the bad flow where you get an error back. But don't copy that automatically to the request body. Copy that manually, copy paste it and add it to the end of your request object, and OutSystems will automatically generate the error structure for you as well. If the REST interface doesn't give you an error structure back, you can always manually add your own structure to the response body, and that's available for you as well in the action that makes the REST interface available. What you do then is, in your after response, you can always catch your HTTP status codes if it's not a 200. Depending on what you want your user to see, you can reset your HTTP status code back to 200 and add the error to your customized error structure. Mainly use your on-after response for exception handling. It's a good way to guide your user through the application if something goes wrong. With that said, I want to end this session for today. Hopefully it will benefit you in making some good applications in OutSystems, especially with REST API. If there are any questions, let me know. It doesn't matter what kind of questions. Don't make them too difficult. And hopefully I'll see some good applications come by. Enjoy.